Postharvest physiology and technology is the key to maintain and extend the shelf life of perishable foods and reducing food losses. Postharvest physiology is about the plant response to technologies and other applications that extend shelf life and quality. However, post-harvest losses are still significant, and reduction of such losses would be the easiest, less costly, and most effective method instead of increasing the food production. Quality itself includes aspects that are appealing to consumers such as appearance, aroma, taste, color, reduced risk of foodborne pathogens or pesticide residues, or denser nutrient or phytonutrient content. Growers and shippers realized that keeping produce of flowers cold greatly extended the shelf life, and this stimulated much interest in exploring the causes of plant senescence at physiological, cellular, and molecular levels. As consumers continue to increase their daily intake of fruits and vegetables, pressure to deliver high-quality product with a longer shelf life is critical. Quality is made up of many attributes, both intrinsic and extrinsic, which vary depending on the expectations and memory of the consumer. The intrinsic features of the product include key external attributes such as color, shape, and size, as well as freedom from defects. Internal attributes include texture, sweetness, acidity, aroma, flavor, and nutritional value, as well as freedom from unsafe components. The extrinsic factors refer to production and distribution systems, including the chemicals used during production, package types and their recycling capabilities, and the sustainability of production and distribution in relation to energy utilization, which also influence consumer acceptability and decision.
From the time the crop enters the front of the harvester to the time it comes off the end of the freezer belt in the factory has got to be no more than 150 minutes, so 2.5 hours. Produced in that time scale, it retains all the vitamins and minerals of the pea, and it's the best frozen vegetable product there is, without question. It works very well with freezing and it retains all the goodness and the sweetness. I'm Richard Fitzpatrick, and General Manager of Holbeach Morass Cooperative. We are a cooperative of about 30 grower members producing peas for freezing. This crop will only be at its optimum in terms of quality for about 24 hours of its life, so we have to be in here with the harvesters on that day. If we were here tomorrow, this crop will be too old in terms of quality and we'd have to leave it.
What I can't emphasise enough is the relationship that we have with the grower to make this operation a success. We need to make sure that everything from start of harvest to a pea being frozen is done within that 150 minutes.
Quality can be affected by three factors, which are pre-harvest factor, harvest factor, and post-harvest factor. Pre-harvest factors are critical to ensure the production of quality horticultural commodities. The post-harvest quality attributes, post-harvest physiology, and life of fresh horticultural commodities are highly influenced by several pre-harvest factors, including climate and agronomic factors. Although genetic material drives external and internal quality attributes, agronomic and cropping conditions also have direct and indirect impacts on these attributes. The use of different growing techniques, manipulation of environmental conditions, nutrients, irrigation, pests, and other factors can have impressive direct and indirect effects on all aspects of the quality, physiology, and life of horticultural commodities after harvest. Soil management, fertilization, irrigation, and agricultural practices influence mineral composition, storability, and susceptibility to certain disorders and diseases. Chemical treatments such as growth regulators can modify fruit attributes and susceptibility to specific storage disorders and may contribute to variability in the storage potential of certain fruits. There are two causes of post-harvest losses, which are internal and environmental factor. Post-harvest losses vary greatly among commodities and production areas and seasons. As a product moves in the post-harvest chain, post-harvest losses may occur from a number of causes, such as improper handling or biodeterioration by microorganisms, insects, rodents, or birds. Apparently, there are internal and external factors contributing to post-harvest losses. Internal factors that may contribute to post-harvest losses can be found at all stages in the food supply chain, from the moment of harvesting to handling, storage, processing, and marketing. The primary causes of losses at harvesting stage include the absence of an established maturity index for some commodities and lack of maturity index for local export markets, low adoption of established indices as price and distance to market influence adoption, and poor weather at harvesting time, which affects the operations and functionality of harvesting machines or human labor and usually increases the moisture content of the harvested products. Loss is also caused by employment of improper harvesting methods such as rough handling, untimely harvesting, lack of appropriate and poorly designed harvesting tools, equipment, and harvesting containers. Secondly, pre-cooling process involve losses due to the high cost and lack of availability of pre-cooling facilities, inadequate training on pre-cooling technology at the commercial scale, and lack of information on cost benefits of pre-cooling technology. Primary challenges in the transportation stage of the supply chain include poor infrastructure, lack of appropriate transport systems, and a lack of refrigerated transport. In most developing countries, roads are not adequate for proper transport of horticultural crops. Also, transport vehicles and other modes of transport, especially those suitable for perishable crops, are not widely available. Besides, in storing process, facilities, hygiene, and monitoring must all be adequate for effective long-term storage. In closed structures such as warehouses, Control of cleanliness, temperature and humidity is particularly important. It's also very important to manage pests and diseases, since damage caused by pests and molds can lead to deterioration of facilities and result in losses in quality and quantity of food. Next, at the grading stage, proper packing and packaging technologies are critical in order to minimize mechanical injury during the transit of product from rural to urban areas. Causes of post-harvest losses in the grading stages are lack of national standards and poor enforcement of standards, lack of skill, awareness and financial resources. Packaging and labeling. After harvest, fresh fruits and vegetables are generally transported from the farm to either a packing house or distribution center. Farmers sell their produce in fresh markets or in wholesale markets. At the retail level, fresh produce is sold in an unpackaged form or is tied in bundles. This type of market handling will greatly reduce the shelf life of products. Causes of post-harvest loss in secondary processing stage include limited availability of suitable varieties for processing, lack of appropriate processing technologies, inadequate commercialization of new technologies and lack of basic infrastructure, inadequate facilities and infrastructure, and insufficient promotion of processed products. Biological causes of deterioration include respiration rate, ethylene production and action, rates of compositional changes, mechanical injuries, water stress, sprouting and rooting, physiological disorders, and pathological breakdown. The rate of biological deterioration depends on several environmental factors, including temperature, relative humidity, air velocity, and atmospheric composition, which are concentration of oxygen, carbon dioxide, and ethylene, and lastly, sanitation procedures. In microbiological process, microorganisms typically cause damage to stored foods. Usually, microorganisms affect directly small amount of the food, but they damage the food to the point that it becomes unacceptable. Toxic substances elaborated by molds cause loss in food quality and nutritional value. Last but not least, most of the chemical constituents naturally present in stored foods spontaneously react, causing losses of color, flavor, texture, and nutritional value. One such reaction is the Maillard relation that causes browning and discoloration in dried fruits and other products. External factors are the factors outside of the food supply chain that can cause significant post-harvest loss. These factors can be grouped into two primary categories, which are environmental factors and socio-economic patterns and trends. Many environmental factors, such as temperature, humidity, altitude, and time, determine major physiological and biochemical processes during fruit development, maturation, and ripening, with these processes greatly impacting fruit quality. The first factor which may greatly influence the quantity and quality of a harvest is temperature. In general, the higher the temperature, the shorter the storage life of horticultural products and the greater the amount of loss within a given time. This is because most factors that destroy the produce or lower its quality occur at a faster rate as the temperature increases. The next factor is humidity. There will be movement of water vapor between stored food and its surrounding atmosphere until equilibrium of water activity in the food and the atmosphere is achieved. Fresh horticultural products have high moisture content and need to be stored under conditions of high relative moisture loss and wilting. On the other hand, dried or dehydrated products need to be stored under conditions of low relative humidity in order to avoid absorbing moisture to the point where mold growth occurs. Other than that, altitude also plays a role in determining post-harvest loss. On average, for each kilometer increase in elevation above sea level, there is a drop in temperature of 6.5 degrees Celsius. Storing food at high altitudes will therefore tend to increase the storage life and decrease the losses in food, provided it is kept out of direct rays of sun. Lastly, the longer the time the food is stored, the greater is the deterioration in quality and the greater is the chance of damage and loss. Hence, storage time is a critical factor in loss of foods, especially for those that have a short natural shelf life. Socio-economic factor is another external factor that significantly contributes to post-harvest losses. Social trends such as urbanization has driven more and more people from rural areas to large cities, resulting in a high demand for food products at urban centers, increasing the need for more efficient and extended food supply chains. Other socio-economic factors are linked with grain importation, which can introduce new insect species, hence posing a very serious problem for both imported and native grain. There exists a list of strategies which fit to be applied for perishable crops including fruits and vegetables. The strategies will mention the promising practices and technologies to reduce post-harvest losses. The first stage is during harvesting of the crops. Harvesting should be carried out as carefully as possible to minimize mechanical injury such as scratches, punctures, and bruises to the crop. The time of the day when harvesting is done also affects produce quality and shelf life. In general, harvesting during the coolest time of the day is desirable so that the produce is not exposed to the heat of the sun and the work efficiency of the harvesters is higher. If harvesting during the hotter part of the day cannot be avoided, the produce should be kept shaded in the field to minimize product weight loss and wilting. At sorting and cleaning stage, systematic sorting or grading coupled with appropriate packaging and storage will extend shelf life, maintain wholesomeness, freshness and quality, and substantially reduce losses and marketing costs. Sorting is done to separate poor produce from good produce and further classify the good produce based on other quality parameters like size. Followed by packaging stage, a proper packing is essential to maintain the freshness of leafy vegetables. Packaging should be designed to prevent premature deterioration in product quality and to serve as a handling unit. Clean, smooth, and ventilated containers must be used for packaging. Besides, the strategies to minimize losses during transportation mainly refers to vehicles, equipment, infrastructure, and handling. Load and unload transport vehicles carefully. Use clean, well-ventilated vehicle covered at the top for transportation. Transport crops during the cool part of the day by driving carefully over smooth roads to minimize damage to crop. Fresh produce must not be watered prior to loading, as this will lead to decay, rotting, and extensive losses. Then, at storing stage, only crops with high initial quality can be stored successfully. It is therefore essential to ensure that only crops of the highest quality are stored. Shelf life can be extended by maintaining a commodity at its optimal temperature, relative humidity, and environmental conditions. Lastly, processing is an important value-added activity that stabilizes and diversifies food supplies and creates employment and income opportunities. It can minimize the high perishability problem of leafy vegetables. Processed products are also more stable, have improved digestibility, and permits a better diet diversity, giving consumers access to a wider choice of products and a wider range of vitamins and minerals. A few common and effective processing technologies are drying, salting, fermenting, and pickling.